everyone. Hello and welcome back to Nick Does Algos. In this lesson, we'll be covering the Hackerrank easy rated algorithm, Lisa's workbook. So to explain what is going on in this problem and what we are being asked to return, we are provided an array of numbers, and each index represents the number of problems in a chapter. So for this array here, this first chapter has 4 problems in it. This second chapter has 2 problems in it. And what K is the number of problems that you can fit on a page. So for chapter 1, you have 4 problems. That means on page 1, you'll have 3 problems. And then on page 2, you would have another problem. And then from there, your book keeps going, but it goes into the next chapter. You turn the page because you're changing chapters, and then you put 2 problems on that next page. So in this book, you would have 3 problems on page 1, 1 problem on page 2, and 2 problems on page 3. And what are we actually looking for in this question? What does it want us to return? Well, it wants us to return a special problem. What is a special problem? A special problem is anytime the problem number and the page number that it occurs on correspond to each other. So in this example, that happens in chapter 1, and chapter 1 only, actually. In chapter 1, you have problem 1 of chapter 1 that occurs on page 1. And so the chapter doesn't really matter. The significance of the chapter really comes in hand when you are changing pages. But other than that, it's not really important for determining if the problem is a special problem or not. In this case, it just so happens to be chapter 1, page 1, problem 1, but what really matters is just problem 1, page 1. And to explain that further, say you wound up having problem 10 occur on page number 10. And that could be in chapter 1, it could be in chapter 2, it could be chapter 3, or whatever. As long as the problem number and the page number correspond to each other, you have encountered a special problem. So I hope that makes sense. I hope it's clear. If not, read this explanation down here. Should make a little bit more sense. And take some notes, and I'm sure you will start to understand what's going on. So with that, let's head over to Replit and start to get to work. The way we're going to solve this problem is we're going to walk through the problem numbers and increase the page number as we walk through the problem numbers based on specific criteria. Based on specific criteria that are explained in the Hackerrank problem. So to start out, let's go ahead and initiate an answer variable and set it equal to 0. And that will store what? That will store the number of special problems. So of course, we are going to start out with 0 special problems, and as we find them, we will increase that answer number. The second thing we're going to initiate is a page variable. And our book is going to start on page 1. We don't need to start on page 0 because we wouldn't put anything on page 0. As indicated in the Hackerrank problem, we'll start on page 1 and start putting our problems on that page. So first, what should we do? Well, we're going to want to loop through our array, our provided array, and change the page and increase the numbers based on our specific circumstances. So for our first iteration of our loop through our array to build out this book, we can write 4 probs in array. Probs is really the number of problems in a chapter. So you could write chapter there, you could write probs, whatever works best for you, but we're going to stick with probs in this scenario. And then we'll want to create an internal loop. So our external loop represents the number of problems in each chapter, and then our internal loop will actually go through those problems. So we can write for problem in range 1 to, we want to include the last problem, so we'll do probs plus 1. And to be clear, what is that? Well, this range says that we will loop from 1 up to our probs value. And what is our probs value? Our probs value is 4 for this first chapter. So that means we will go through problem 1, 2, 3, and 4. And then based on that number, we will do something to our answer, and we'll also do something to our page number. Okay, so first let's tackle the answer. So think about the first loop. Think about the first chapter. Problem one is going to occur on page one, right? So we're already on page one and we're going to encounter problem one. So really nice and simple way to do this is just say if problem equals page, we can answer plus equals 1. And there you go. We found a special problem. But what happens from there? Well, problem goes to 2. Nothing happens there. And then problem goes to 3. And nothing happens there. But something should happen there, right? We've reached our K. We've reached our maximum number of problems on one page. So we would then say if problem, and we'll write this using a modulus, if problem modulus K equals 0, we'll go ahead and turn the page. And then we'd be on page 2, right? Page 2 would fit problem number 4 on it. And then we'd turn the page again. And why would we turn the page again? We turn the page again because we have reached the end of the chapter. And how could you say that you have reached the end of the chapter? Well, you could say that you've reached the end of the chapter by writing an OR condition if problem equals probs. Because remember, what is probs? Probs is the value of the problems in the chapter. Like I said, you could do problems here, you could do chapter here. But what it represents is that you have kept track of all of the problems in that chapter, and it's time to go to the next chapter. So that happens when problem equals probs, and then you would change the page. Okay, so let's make sure this works. Let's run a quick print, and let's print the answer. I believe the answer for this example is 4. Yeah, there was 4 from my last time I ran this, and there you go. We have solved this. So let's pop it back into Hackerrank to make sure everything checks out, everything works, and looks okay as far as format goes. So let's run that code. Oh, I'm sorry. We need to return, not print. Return. If you're like me, I'm sure you've made that mistake hundreds of times. Okay, and there you go. We pass both sample test cases. Let's go ahead and submit it against all the test cases. And there you go. We pass all of the test cases. So I hope that's clear. I hope that's making sense. If you have any questions at all, please feel free to drop them in the comments down below. If you like this video, if it helped you out, please go ahead and hit the like button. And of course, we cover these algorithms just about any day. New videos go up just about every day. So if you are also covering algos basically every day at this point in your career, you're going to want to go ahead and hit the subscribe button. So thank you so much for watching. Hope to see you in the next one.